Hello everyone, it's a pleasure to be able to give this talk during MS Tech Summit this year. My subject for today is the future of data-driven decision-making, exploring AI trends with examples from Azure Data Stack. I'm Marek K, co-founder and CTO of at Consensus. Quickly, a few words about me. I have more than 15 years of experience in data domain. My background is software development. Many years ago, then I got into data science and machine learning. Currently, I'm focusing on data engineering for business intelligence and injecting machine learning and NLP into this process. My academic background in part is not obvious. It's solid state physics and data warehousing. What I will be talking about today is first the importance of sound data engineering, how big of a part it is for data related projects, getting from the sources of data to the visualization and getting insights from the data. I will also mention a few trends that we're seeing either from our experience when working with clients or also survey results from research. One of those trends that I see as important this year is the consolidation of the data stack. I will talk a bit more about it. The reason is for sure the economic environment this year, reduction in development team sizes, companies having tighter budgets. Also, I will be talking about essential data technologies for BI projects. So a few examples, mostly from architecture standpoint and specific data tools from Microsoft Intelligence Data Platform, mostly Azure Stack. And last but not least, a notable mention, probably last year, even 3 months ago, I would not be talking about it yet, but after recent advancement in large language models, it's pretty much a must-have right now. It all comes down to how can this all drive value and trust in the insights from data that we're using in the companies. So first, I would like to put a few concepts in your mind that for me act as a roadmap to a successful business intelligence project. So first, that would be data quality. Business intelligence projects rely on accurate and reliable data. You should be able to trust that what you're seeing, that it's actually grounded in your source data and correct transformations are applied. The other thing is data accessibility. This is where data engineering layer comes to the picture to get your data from the source to a structured and standardized format that allows you to do analytical queries. Then we have data security. You need to make sure that data is properly backed up, protected from unauthorized access. Then we go into cost efficiency, so optimizing data storage, data processing, data retrieval. And you want to use the skill set in the organization in the most effective way, especially that those might be pretty expensive and valuable resources if we think about the data team. The last thing is scalability. You might have growing use cases for your data, or on the other hand, growing data sources, and you want to be able to query them efficiently. Again, optimized data engineering layer comes to mind here. Okay, so if we ask this question, who wants to do data analysis, then we see a lot of hands, either from business analysts or from business intelligence developers or from data scientists. And that's what they thought actually. You get data in this nice tabular form, and you can start analyzing it. Seems easy enough. But let's remind ourselves that what we're trying to achieve here, so to go from data sources to the visualization part, to be able to consume it, make business decisions based on insights from data. So this can be business intelligence dashboards, or from data scientist perspective, Jupyter Notebook, for example, but we need this layer in the middle. And then we ask a different question. Who wants to clean the data? And cleaning data is usually part of data engineering. So who wants to do data engineering? And then we get a lot less hands and volunteers for that. Perhaps one of the reasons might be that if you think about it, there is this real life monster in the data. Maybe not always exactly like the one in the picture, but if anyone in real life tried to dig into data problems, this can get scary. Going further with question from a survey done by Dataversity, Trends in Data Management, why even care about data architecture? What are the benefits? Here we can ignore the very top answer that we don't have a defined architecture. That's what you want to avoid, obviously. But we see that main two benefits of caring about it. It's improved collaboration with the business team and improved collaboration within the IT team. So for me, that translates into a trend of cooperation of business and IT, and it's like a holy grail of productivity. A lot of times in the projects, we see this schism between IT or data team and business. Sometimes, unfortunately, there is very little cooperation. From our perspective, when getting insights from data, this is crucial. Because your data team is trying to do something that should drive business. And you need at least some relation of what you see in the data and what it represents in real life. So here, I will be talking about such a tool from Azure Stack. Also quickly wanted to point out a few business intelligence trends that I personally see for this year. Those trends are also visible in BARC data in their surveys. So here I've put data governance, data literacy, and data-driven culture together. And I think they should be considered as a whole. Two main points that make this important. The significance of data-driven decision is constantly rising, and there is nothing on the horizon that could slow it down, I think. Second thing, we'll soon have new regulations regarding data and AI. European Union is working on AI Act, and US and Canada are also working on the regulations. China recently published their own. So the recent advancements in large language models like ChatGPT and more specifically GPT 3.5 and GPT-4 accelerated that even further. So then the second trend, consolidation of the data stack. I will discuss in a bit more detail in a second. Then we have the slow rise of a separate semantic layer. We want to decouple, for example, measure and definitions from the actual BI and visualization layer. Then data security, I don't think I need to comment on that, just must have for various reasons. And trend 5, where also slowly but gradually something that is very well solved in software engineering development is coming to business intelligence, and that is continuous integration, continuous deployment, and automated testing for business intelligence. And the last trend, which I would not consider a few months ago, so I guess most of us were taken by surprise how quickly it can grow, with ChatGPT being the fastest app to reach 100 million users in just 2 months. It still has specific limitations if we think about enterprise versus private usage. And now I wanted to focus on the consolidation of the data stack. So on one hand, even last year, the data stack was still growing almost uncontrollably. That's the black hole in the image. A lot of new data tools, a lot of new platforms. And on the other hand, we have the current economic environment and the drive to reduce costs. That's the reason for reversal of this trend of growth. We now actually want to get all our tools from the data stack and integrate them more so we have a unified data environment that's easier to manage. So we want more centralized data management. And why is that? Well, in ancient times, that's basically all we had. It's SQL Server, Oracle, then SQL, C++, Java, and that was all our stack for doing data engineering. Well, back then it was not even yet called data engineering. And if you think about it right now, then that's how it looks. Well, technically, this is from 2021, and that was still readable, but I hope you get the point. We had almost exponential rise of different tool sets. And if you think from the perspective of your skill sets in the organization, how to manage those skills for all those data tools, like how do you do that, right? So the idea is to focus, use the skill set that you have in the organization in the most efficient way. And the alternative, in my opinion, is that probably most of the time will be spent on learning those new tools instead of doing actual data engineering and getting business insights. Okay, so let's go through the essential architectures for business intelligence. We have the old reliable data warehouse architecture, where you have enforced schema that's specifically designed for fast analytical queries, and data lake architecture, where you can store data in raw format. It allows you to store unstructured data on top of any other type, and it's very fast when you want to say things and throw it there. Also very cost effective. But you have the concept of schema on read, which, well, it turns out that it's not so easy to implement schema on read that is fast enough for analytical needs. For now, a lot of transformation and data engineering is needed as an enabler for getting insights from data this way. This might change, maybe not yet in the very short term, but I think we might be getting there, looking at some machine learning, like AI models that can analyze tables, getting insights from them. And like I hinted previously, I will be mentioning Azure OpenAI Service later on. And we have then the third concept of virtual data warehouse, where you theoretically do not move data from the source. You just have this layer in the middle that enables standardized access to your data for analytics. So also caching for fast querying, but you get the middle layer and try to avoid moving the data from one storage to the other. And last but not least, you get the hybrid architecture that connects those concepts from the world above, and I will be talking about it in a minute. And here I wanted to mention again the survey from Dataversity Trends in Data Management, This time the question was about usage of data lakes and the comparison between 2020 and 2022. And if we look at joint, yes, I'm using a data lake, and no, I'm not using data lake, all those look pretty stable, not a lot of change. But if we dig a bit deeper, there's something interesting in how data lake is actually used. And looking at the top answer, then it says it's in conjunction with data warehouse. So this is a hybrid setting. And here it was 26%, now it's 34%, so a rise of 8%. Then we have the answer yes as the replacement of the data warehouse, which looks like stable at 5-6%. I would think that those are late adopters that just caught on the hype of data lakes. And then another answer, yes, we use data lake as its own solution without the data warehouse. Then we see drop of 8%. So looking at those numbers, well, they're actually confirming what we see implementing data engineering and BI. It's quite clear that the way data lake is utilized is changing into this hybrid architecture, and that's how you arrive at the concept of data lake. So going from the left, we have the old reliable data warehouse with structured data out for schema, then a data lake where you can save everything in a cost-effective way, structured, semi-structured, unstructured data, but it can be garbage in, garbage out. It's hard to manage. And then we have the data lakehouse concept where you still utilize the storage based on the data lake, but you have a meta layer with metadata governance and standardized access for all your use cases. So it can be business intelligence, it can be visualizations, data science, machine learning. So that allows standardized access layer to that. And let's get back to earth a bit with this data from BIRC survey. That's actually BIRC, they are doing a very good job measuring digitalization in a business setting, so very good data source to check. The question here was which technologies you're using for data access. And while there are some voices that data warehouses are dying and will go away, the reality actually disagrees. This is a quite recent survey, and we see that data warehouse is there on top with about 70%. So it's still used, and in my opinion, because of schema enforcement and fast analytical queries, it will be used for business intelligence use cases. Then the second answer on the list is business intelligence, like in general, which tells an interesting story that most of the uses for utilizing data in business will be when you are able to move the data from the source data engineering layer to the BI platform. And then you enable your business users to use the data. They're not so keen to dig in the mud actual source system. So this is pretty important to allow your users to have access to data. And then there is immortal Excel. So like a lot of times in a BI perspective, you can have a shining dashboard with KPIs, which is okay for quick daily checks, but a lot of times you want to export a sample of the data to be able to dig into that. That most likely be in Excel. Then of course we have the code and programmatical access to data. So that would probably be where Jupyter notebooks would lie and data scientists accessing the data. And the last thing here, like probably also I don't like how this question was asked. It puts a lot of different concepts from different domains into one. And I think there is a lot of misconception about data mesh and data fabric, that it's somehow platform versus platform or data mesh versus data fabric. But I think those two should be taken out into separate category, because data fabric and data mesh are strategic approaches to handling data in your company. You can implement data fabric and data mesh in various forms, and you can have both at the same time. They are not exclusive. So data mesh is something more focused on data as a product with a concept of decentralization and federalization of data. And then data is domain oriented there. So you get different departments and you enable them to use their specific data for them. So it's more focused on how you use the data. And data fabric is an approach where it's most focused on the unified platform, where you enhance the data either via AI or trying to build a standardized interface for all your users to access it. So here it's more focused on the platform. But data mesh and data fabric are not exclusive. They are implemented by using specific tools, and you can implement both using Azure Stack. But it's again how you on strategic level approach data handling in your organization. Okay, so essential technologies that you would need to do a business intelligence project. What do we need? And to have the ability to make data-driven decisions. For sure, we need an ETL EL2 tool. Right now, if you're thinking about data lake or data lakehouses, it would mostly be extract, load, and transform. Then you need data storage. You probably want a data lakehouse to get fast analytical queries and flexibility. And here I put the semantic layer between data storage and BI platforms. For me, yet while this is a trend this year, we're going in the direction. I don't think that there is yet an ideal implementation of a full semantic layer. So that's why it's not yet a separate feature, in my opinion. Hopefully it will change, as a fully separate semantic layer has a lot of benefits. Then we have BI platform, which in the context of Microsoft, I think is pretty obvious, would be Power BI. But what not everyone knows, curiously, is that there is a licensing option between the pro license for users, which is very cheap or even included sometimes in E5, but it is included in E5, and the premium capacity, which is pretty expensive per month and usually makes sense above around 200 users. But there is something in the middle, a premium per user option where you get the benefit of premium capacity and features like deployment pipeline for separating development, testing, production, and you get this in a nice pricing option that scales with single users. And then last but not least, data governance tools. And here in the context of Microsoft, it is Microsoft Purview. From my perspective, a great tool that allows you to automatically scan data, build end-to-end data lineage, and like from your data source to the BI reports. A pretty powerful feature if utilized in a smart way. Of course, most of those concepts are not that new, but most of the developments that actually make all those tools really useful happened in the last 6-8 months. Well, Purview and Power BI API is continuously developed. So it's actually almost weekly sometimes that we see important functionality making it to preview or testing. Okay, so let's first focus on the ETL tool. An example of such a tool from the Azure Stack would be Azure Data Factory, which in essence allows you to connect a variety of data sources using a predefined connectors, either a database source, SQL or NoSQL. Essentially, we built a data pipeline where we either copy the data from the source to the destination or do some transformations with it. Interesting thing is, if you know Power Query, which most Power BI developers do, then actually in Azure Data Factory, there is this component where you can build transformation using Power Query. If you think about where it fits into the data stack of business intelligence, then it's usually right next to the data source systems. You move data from the sources to the storage and then go from there with analytics, ending with Power BI. So that's something we've utilized a lot of times, and it does its job pretty well. I'll show a more detailed architecture later on. Going to the next tool, which I think realizes both of those functions. So not just data storage, but also the ETL part. That's why I left the ETL point still bolded. That would be Azure Synapse. What it is, a platform that allows you to get your data from source, similarly as in Azure Data Factory. A lot of components are similar there. Curiously, not every feature from Data Factory made it to Azure Synapse. The old one out is unfortunately Power Query. You cannot use it in Azure Synapse. But essentially, you get a web studio where you can define data integrations, you can manage and monitor your pipelines, and also deal with security. Of course, you also get analytical runtimes, one being the SQL, and the other Apache Spark for custom transformations or injecting machine learning. And it's all backed up by the data lake storage. So you get a data warehouse, metadata layer, and it's all backed up by a data lake. Well, that's a data lakehouse, if you ask me. However, by itself, not yet a tool that would be enough to implement a data mesh, for example, but it can be used as one of the components to implement this strategic approach. And another example, also, I think, realizing the ETL ELT concept plus storage is Power BI data flow, and also Power Platform data flows that are part of Power Automate. Curiously, Power BI data flows are available for a few years now, and it's really puzzling for me that it's still underutilized among Power BI professionals. We've used it for our clients since it was in public preview, and I think it was 2018. And what actually allows you to do is to take Power Query code and put it into a separate data flow in the Power BI service. And this data flow can run independently on the Power BI service in the cloud. And the data will be saved in Data Lake, also immediately accessible from Power BI, already on the same compute capacity. We've used it for performance optimization, and also when we needed to reuse data asset in different reports or connect to it from different data flows. So you get this modularized approach where you have linear data set, because a lot of transformations are already there in data flows. And also as benefit, you can set independent refresh schedules. Then we go to another concept, maybe not exactly realizing storage, and but still in between the storage and the BI platform, and it's not also fully independent semantic layer yet. I'm talking about Power BI datamart. So that's a recent introduction in the Power BI toolkit. I think that datamart is a great name for that, because datamart actually is the concept from data warehousing and business intelligence world that refers to a smaller, more focused subset of organizational data where you can do ad hoc querying. Basically, it realizes decentralization and federalization. So it's usually focused on one domain, for example, just finance or just sales. You put specific domain-oriented data into specific data mart and allow selected department or team to use the data that's there. It is also usually customized and tailor-made for those specific use cases, specific users. And thanks to the limited scope, it can have better performance, easier maintenance. So that's essentially what the Power BI data mart is, exactly what the name suggests. And from the data search perspective, it utilizes data flows and also other data storage. It doesn't really have its own. It allows you to access the data, and it's powered by Azure SQL DB. For me, it's kind of a step into the direction of semantic layer, because it allows you to define a specific domain-oriented view on the data. You cannot yet fully define measures there as you would in Power BI, but maybe since dbt is pushing quite hard into features like full semantic layer, I think we'll see something similar here. The last tool I wanted to show from the stack would be a data governance tool. So here, since we're keeping to the Azure stack, and it's actually a very good tool, and it's Microsoft Purview. I must say that the road it traveled from like a completely unusable data catalog a few years ago to what Purview is now, but they are not really connected like in history, but Purview has a data catalog that is implemented really well, I think. So that's really something. In my line of work, I'm constantly comparing different data governance tools, mostly from data engineering perspective, but also from the perspective of collaboration with business. And Purview is a very focused tool. It has the most important things that you actually need in Power BI, like in BI projects. That is data catalog, data map with a glossary that allows you to access data assets and connect them to business meaning. And just to quickly go through, you define data sources, you define scans, and you can scan your databases or data sources, and you get data assets into Purview. You can then build glossaries, and business glossaries, when you put the definitions of business meaning assigned to specific data. That can be either tables, data flows, even columns, and you can make a link between a data and the glossary item. So from the business perspective, you can go from a business concept to how it is represented in your data. And from the data engineering perspective, you can go into a specific table or specific column and see what it represents as a business concept. And the other thing you get is data lineage, and also end-to-end data lineage, which is just even more exciting. So where you can go from the source of data to the end destination, for example, your Power BI report, which allows you to do two main things. So one would be root cause analysis. So you go from the Power BI report and through transformations to the source of the data. So like, let's check what happened along the way with our data. But we can also do it in reverse. So from a data source or data sources, again, through any transformations to the destinations. And for example, it could be multiple Power BI reports or data marts or analytical views. And then we can do impact analysis. So we plan a change, and we can immediately see what influence and where would it have going forward. That's a pretty powerful, and I would argue unavoidable when you want to implement data-driven decision-making and to be able to trust it and maintain it. And we'll keep to the data lineage. Then we have a few levels that we can get. First, it would be data assets on the level of tables and reports. Then you can also get to the column level. And so we can actually trace a specific column, how it goes through the transformations to the report. And you can also get to the level of process or data activity if you stay in the Azure stack and scan data factory. Then you're get quite a lot of details about what happens with your data along the way. And how you can get that, one thing is you define scans, as I already said, and it scans your data transformations, build this lineage automatically. And if you keep to the Azure Stack, you can get end-to-end lineage from the source to even your Power BI report. If you use another data warehousing solution like Snowflake, which we also did in another project, then there is a small manual step that you need to do to actually have this end-to-end data lineage. Also, like a hack is needed because you cannot connect manually to a data set. It has to be a different data asset, which is Power BI report, but you still can do that. And the last part, Purview, is based on Apache Atlas API, so you can also programmatically push changes to Microsoft Purview, and that allows you to quite a lot of flexibility. You can programmatically push the changes to your data governance tool, and also have infrastructure as a code in a way. Just a short intermission here. We usually want to gather as much feedback from the market and from community. So here, I invite you to take a short survey. You can use the QR code or this link to access the survey. If you leave business contact details, we have 3 prizes in the form of free workshops focused on Power BI, Azure Synapse, and Microsoft Purview, specifically for your needs. And if you just want to leave feedback, then that's what we're after. This will be anonymized, and we'll be using that to share insights about the BI market with the community. So next, I wanted to show a few architecture examples taken from our projects, of course, to the level that we can show them given our NDAs, and not the type of architecture that is visible in the AI-generated image. I mean, system architecture. So on the left side, here, this is the data engineering layer with Azure Synapse feeding Power BI. So on the left, side, we had database sources that we could use with connectors from Azure Synapse. We had external APIs, few of them had hierarchical structure that was not easily translated into tabular form. So we needed those custom transformations, for example, that we've done in PySpark notebooks. And we also had some data sources behind the virtual network, essentially on-premises data sources. So for accessing that, we needed authentication layer. And for APIs, we used the registered app and Azure Key Vault, where we securely stored the credentials. So that's the recommended approach for doing that. And for the on-premise sources, we had a separate data factory that was able to access this virtualized network. So we just copied the data into the data lake in Azure Synapse. And inside Azure Synapse, we used data pipelines, SQL procedures, and PySpark notebooks to transform the data. And finally, we had a dedicated SQL pool that provided data to the Power BI reports using the query. And what's also important from the data engineering perspective about Azure Data Factory or Azure Synapse, it's like they are local tools, but they are still defined by config files in JSON structure, having JSON structure. So underneath, they're actually code. This allows for very interesting and useful concepts to be utilized. Like we can do code versioning using Git and implement continuous integration, continuous deployment concepts using Azure DevOps. And that's exactly what we did on this project. There's also a possibility to utilize infrastructure as a code, since this is the code underneath. And actually using the Azure DevOps does it in a way when you publish the changes. If you look from the left, we have development workspace where you create development branches where those small changes are done, and those are pushed with requests for review and acceptance. And once that is done, then it is merged into the development master branch, then published into specific workspace publish branch, and that triggers an automatic Azure pipeline, which moves it to the test master branch. Then it can all be tested there, and if tests are successful, then again, using Azure Pipeline, it can be put to the production workspace. Another architecture, this time utilizing datamarts. And this is actually, as I already mentioned, an implementation of a data mesh approach, because we're utilizing here the concept of decentralization and federalization and focused data marts that could be regarded as a product. So again, going from the left side, what's happening on this diagram is we had the data sources, database source, external API that we needed to transform, and SharePoint data source. Again, we need authentication layer with registered app and Azure Key Vault for storing credentials. Then data is moved to a separate data flows. Essential transformations happen there. So that is the storage part. And then since we needed data from different data flows, we now focus on business domains, for example, department. So one data mart is finance, the other sales, and yet another datamart can be other operational process. And then, of course, Power BI reports for visualization and easy access to this data. And last but not least, another component, Microsoft Purview, to scan the data assets and handle data governance. Let's recap the benefits of this particular stack for business intelligence and enabling data-driven decision making. So first, this actually plays into the trend of consolidated data stack. So here you get the data lakehouse tool, at least, which is Azure Synapse. You then have Power BI, which here represents the whole service, data flows and data marts. So you can implement data mesh approach with those tools. And with Microsoft Purview, you get oversight and governance. And since it is a data discovery platform, and together with Synapse and data marts, those can actually implement the data fabric approach, where you enhance metadata and build a standardized interface. From my perspective, exactly how to handle data literacy initiatives in organizations, or how to support them. And as hinted in my agenda, I wanted to mention one more component, just a quick digression. Here I asked GPT-4 to generate a prompt for Stable Diffusion model to generate an image illustration. Here you actually need to provide an example because image generation prompts are pretty specific. But with this example, it did a pretty good job, I think. And also, this is not a vanilla Stable Diffusion, but a fine-tuned checkpoint, Redshift diffusion, specific styles that you want to achieve. And until recently, it was more of a hype than enterprise-ready solution because still even now, most accessible way to use GPT-4 is via OpenAI, either as ChatGPT Plus or via their API. And I argue that right now, and perhaps still for some time, it's the only such useful conversational model. Of course, there are other foundational models out there, some open source, but so far, in my opinion, GPT-4 is the best fine-tuned LLM available commercially. But if you access OpenAI directly, you need to send data to their servers, so you need to be careful what you send. And for our data analytic purposes, especially in EU, sending data to US, well, that is not enterprise ready. However, Microsoft seems to be working hard to make it ready for wider business use cases. So Azure OpenAI Services. This is a part of Microsoft's cognitive services. Access is still limited, but it's coming, and it seems like we'll be able to inject that also in BI pipelines, among other numerous use cases that we have. As of now, it's still behind the waitlist, especially GPT-4. That's also accessible through Azure OpenAI Service. And looking at the pricing, GPT-4 right now is accessible just on US servers, but you need to submit the request first for the Azure OpenAI Service and then separately for GPT-4. Microsoft would review your use case before granting this limited beta access. There are many reasons, in my opinion. Two main ones is first, high computational cost. Second, responsibility for AI use cases. It has been talked a lot, so they are very selective about what they accept. Okay, and just one example of what's possible, and this has been improving with the latest iteration GPT-4. I tried it in the past. It was making mistakes. So diagram generation, well, it cannot do it directly, but just for fun, I asked it to generate a mermaid script that would generate a diagram, and a diagram for a BI architecture that would include Azure OpenAI Service. And I think it did a pretty good job. Going from the data sources through the ETL processes and even a semantic layer here to BI tools. And then we see the Azure OpenAI component going back and forth from Power BI, and this is how it could actually be implemented. Okay, and a few slides from a short tech demo that we did. So let's assume we have a simple visualization about sales and different regions. Here on the left, we have a map showing bubble sizes based on sale quantities. And on the right, on the top, we have pricing trend per region. And below on the right is the trend for sale quantities. And both the underlying data as well as the chart itself could be converted to JSON data, as seen on the left side. We have product, quantity, price, date, region. Then with a little bit of prompt engineering, we can pass that to a language model via API and ask it to provide insights on those data. And again, prompt engineering here is important to force the response in a JSON structure, so it can be parsed on Power BI side. So the prompt we used was close to this one, defining what we want to get, specifying the placeholders. Here it's in one go, but I will mention later that maybe it would make sense to separate insights from recommendations. and to utilize different temperature parameters in the API. We can also ask it for a numerical confidence level for each analysis and see what comes back with it. So going back to our pipeline, usually an important step is to also send the initial response back for a quality check. So this usually improves the accuracy of the response, kind of allowing it for self-correcting. And finally, as a result, we get the predefined data structure that we can specify with categories, insights, or recommendations, and specific subcategories in a JSON format. And since we also ask for a numerical confidence level for each analysis, we have those in the result. While it's still something to be thoroughly tested and might not be a very reliable score since it's self-scoring, and I don't think any fine-tuning was done for such a self-scoring task. But some proof of concepts that we did show that it can at least be an indication that something was bad. And when we have the JSON response from the API, we can parse it in Power BI and show it as a visualization. It's text-based in natural language, like a formatted table does work here. So again, we have insights and recommendations with a confidence score. And it's all based on the previously preprocessed data that were used in the Power BI charts I've shown previously. So looking at some capabilities of large language models, we arrive at an interesting question, because it seems we might be close to garbage in, insights out, although I don't think we're there yet. Perhaps we'll rather need to redefine what garbage is in this context. But, well, law enforcement sometimes look into people's trash bins, and some interesting and useful hints can be found there. Of course, we need to remember that large language models, because there is randomness that's usually driven by temperature parameter, hidden from ChatGPT, so you don't see it, but if you use the API, it's exposed. So we can force the model into more creativity with higher temperature, or you can have something less random with lower temperature. And the thing to be careful about is confabulation, when LLM with confidence use something that's false. And sometimes, quite often, it's incorrectly referred to as hallucination. And I say it's incorrect because the medical definition for hallucination is based on distorted perception from our senses. So usually hallucination involves sight, sound, smell, touch, and taste. Like LLMs are abstract. They don't have those. So what they do is they go into this mode. I will answer your question with confidence no matter what. That's what I'm supposed to do, give you an answer. And people sometimes also go into this mode. So confabulation is exactly that. Generating a false memory or an answer without the intention of being deceitful. I think a pretty accurate description of what happens with LLMs. And that's important because we need to have the correct expectations about the result. It can confabulate and be creative, so it depends on what you want. If factual analysis is what we're after, and then perhaps a lower temperature parameter and more thorough quality checks for the answers will be needed. But I'd say confabulation is not a bug, it's a feature. This randomness is what makes them conversational. We might not always want 100% factual correctness and strict reasoning. If it's supposed to be a recommendation, for example, maybe a good approach would be to use a higher temperature to generate even something out of the box. We praise out of the box thinking in ourselves. And out of the box thinking requires sometimes venturing into like the incorrect area of the response, and then you go back into something that makes sense. So it really depends on the use case. Definitely interesting times ahead, and it might be closer than we expect. So to recap, I talked about the importance of data engineering and how big part of a business intelligence project it always is. I have mentioned a few business intelligence trends. The most important one in our context that I wanted to focus on was consolidation of the data stack. You get a few benefits from it, mainly by focusing more and being more effective with your skill set in the organization. And interesting new possibilities thanks to large language models are coming pretty soon. Of course, not everyone needs it. If you don't have any stable BI solution and BI reports yet, then a better approach to take it step by step. Starts with something small and manageable. Then when a solid reporting base is built, promoted inside the organization, actually used for decision making, then it's a good time to consider adding a use case for something more complex. And going through those benefits, what we ultimately want is valuable insights and insights that we can trust from our data. So insight, value, and trust. And I wanted to leave you with a quote from Jim Bergeson. Data will talk to you if you're willing to listen. Again, like short reminder that we have the survey. You can use the QR code or this link to access it. If you leave us contact details, we have 3 prizes in the form of free workshops. And if you just want to leave feedback, please do. We will anonymize it and use it to share insights about BI with the community. And thank you. If you have any questions, you can reach me either on LinkedIn via this URL or using the LinkedIn QR code or directly via email. Thank you for watching.